Okay, so today we are going to discuss about the RTOS related things. I want to make this stream focused on the RTOS. I had noticed that many of my streams or my videos related to free RTOS is getting high viewership. So it means that most of my current subscribers are interested in the free RTOS subject. So I think I should dig more upon this topic in this live stream. So if any of you have question about the free RTOS, we can discuss it here. Basically, what RTOS is an operating system designed to manage and execute tasks in real time. So the live streams gives an opportunity to discuss a subject in more detail, while in other form of content like in long form content and short form content we have to cut down lot of things which we may want to discuss, but we cannot due to the limitation of the available length of the duration of the video. So RTOS is a detailed subject, and if you are doing an embedded system programming, RTOS is a critical thing to know about. RTOS is very crucial skill for every embedded system developer. It is an operating system kind of thing. It is not a full-fledged operating system just like you watch in a Linux or a Windows or a Macintosh OS. It is not like that, but it is a smaller version. Although there are RTOS related Linux kernels for RTOS available, but the main focus is a lighter version designed specifically for a specific embedded system device and to perform in a real time. That's the main features of the RTOS, that it can execute the task in real time. Most of the time when you are doing an embedded system development, you may aware that the programming is happened in a linear way. It means a sequential execution. So sequential execution means that the program will flow in one by one step. So one step, then second step, then third step, and fourth step. While many tasks need a parallelism, so you need to perform different tasks in parallel duration. In such case, most of the time, a sequential embedded system flow suggests that you use timer interrupts. So if you had done the embedded system programming, you may already aware that you most of the time what you do, you create a parallel uh, timer interrupts and you divide the task in a timer interrupt. This is a very basic concept of scheduling. Scheduling is a concept in of a RTOS. So it is to switch the task between a fixed time scheduling. There are different schedulers available. That's the basic foundation which leads to a full-fledged RTOS concepts. RTOS is not just creating a multiple task like you do in most of the time in free RTOS, or it is in a timer interrupt. It is not task scheduling. It is much more that it allow you to multitask multiple task execution concurrently. So it prioritize based scheduling, which means that task has priorities. If multiple task scheduling has performed in parallel, then some tasks should be given some priority. Preemptiveness of scheduling, which means that task interrupt lower priority ones. And latency is a which means fast response to events, and deterministic, which means that predictable execution time. The most of the time, the components of RTOS are kernel, which means they manage task, memory, and resources. Device drivers interact with hardware, systems, services, provide utilities, timing, and communication. There are some kind of RTOS, which means the hard RTOS, which guarantee that strict deadlines will met. It is required in some kind of aerospace dynamics or military based systems. There are some soft RTOS, which means that prioritize task but not strict guarantee, which means if you are doing consumer electronics, you can use that kind of RTOS. The feature it discuss is the task management, interrupt handling, and synchronization. Synchronization is very important topic. um, Whenever you are doing multiple tasks, you need to create some kind of algorithm which do the synchronization, which means the semaphores and mutex. These are some concepts which are developed to create the synchronization between the tasks. So moving on, there are lot of advantages, and which means that predictable performance, efficient resource utilization, reliability, scalability. There are a lot of application of the RTOS, which means the aerospace and defense, medical devices, industrial automation, robotics, automotive systems, and IoT devices, which means wherever you find an embedded system, you can utilize the RTOS. It is as simple as that. Example of RTOS, there are a lot of RTOS available, and most popular one is a free RTOS. And nowadays the ChibiOS is also very popular, and there is also a version from the Microsoft which is also getting much popularity. There are some challenges into it. It require more setup, and if you are doing some conventional programming like sequential paradigm, you can quickly get the system up and running. If you have very simple sequential program, you do not need an RTOS for that. But when you do need, RTOS will make your life very easy. In ESP32, if you do the ESP32 programming with the Arduino, the ESP32 have a built-in free RTOS setup for you, and you can utilize out of the box. If you are doing the ESP32 programming with the Arduino environment, it is already set up for you, so you can quickly utilize it. Let's see if it can find us some interesting reels for us. I don't think the Facebook have or Instagram have much reels related to the RTOS. Yes, it is not able to find it, so it will not be possible for Meta AI to find some stuff related to that. So let's move to the what it says. Let's see what the GitHub page they suggest. This is a repository of anti-RTOS. While discussing the RTOS, there is a dedicated repository which says anti-RTOS, which means no any RTOS needed anymore. You will see function pointers, QEs, classes, libraries. Not only for Arduino, works with other IDE like IAR, for example. Manipulate with your task without delays. Keys. NT-RTOS is ultra lightweight universal C++ library designed for task management in IoT and embedded applications. It is coded in a single small file, making it incredibly easy to integrate into your projects. The benefit of this library is interrupt kept fast and controllable, no blocking anymore, easy to debug and understand, get an easy way of multitasking, no dummy waiting or blockings, no need to have a deal with critical sections, mutic semaphores, no task stack memory overflows, keep your project based on straightforward architecture. So while the anti-RTOS is omitting the need for all of these, um, but you get an idea that if we are doing things RTOS way, we need to handle all of these. Get rid of the complexity, allow your microcontroller to perform many tasks while using a very small amount of microcontroller memory. This is a crucial point where you need, if you are doing using some library, you need a very small amount of memory. So obviously if you are doing on Arduino, you know the RTOS running is the very limited resources available because of the limited amount of RAM available there and the limited amount of flash there. On the other hand, if you are doing on STM32 where you have more RAM available and more flash memory, you can do a lot better RTOS related things. And ESP32 could offer you a more advanced features of that as well. But this anti-RTOS library offers ways to do things in different ways. Just include this anti-RTOS.h library. Create queues an easy way, and this is how you can create the queues with anti-RTOS.h. You simply create a 4-element queue, F1, F2 and F3 with a 4, 4 and 8, or you can third queue is the 3-element function pointer. Functions are receiving int 32t argument. So that's how they do that. Whenever you want, just push your function pointers and arguments if they need it. For example, button1 interrupt, F1 push, and these how the different interrupts are being handled in the main loop. Or the delay. If you need to pass several arguments, no problem. You may use your own class for the queue. And that's how. Anyways, moving back. The free RTOS and ChibiOS. If operating system were not so useful, we would not be running a single of our desktop systems. In the same way, embedded operating systems provide similar functionality as these desktop OS while targeting a more specialized market. Some of these are adapted version of desktop OS, Yocto Linux, whereas others are built off from ground up for embedded applications like VxWorks and QNX. Few of those OSs can run on a microcontroller. However, when you need to run an OS on something like an 8-bit AVR or a 32-bit Cortex-M microcontroller, you need something smaller. ChibiOS, meaning a small in Japanese, or a free RTOS, here no point of originality. Perhaps more accurate, free RTOS could be summarized as a multi-threaded framework targeting low-powered systems, where ChibiOS is more of a full-featured OS, including a hardware abstraction layer and other niceties. So basically, These are two of the major comparison to it. And it says that FreeRTOS supports a few dozen microcontroller platforms. The most noticeable is AVR, x86, and ARM, which pretty much cover the ESP32 and SCM32 platforms. I mostly work with them only. I rarely go other than STM32 in Cortex ARM series, just like the TVA board. Sometimes, in rare occasions, ChibiOS runs on perhaps fewer platforms but comes with a HAL that abstract away hardware devices including I2C, CAN, ADC, RTC, SPI, and USB peripherals. So obviously, whenever you are doing an embedded system programming, I2C, CAN, ADC, RTC, SPI, and USB peripherals. These are the most important one that you need to know about. Talking about the preemptiveness, which is multitasking, multi-threading preemptives, including variables and semaphores. So FreeRTOS is good for basic multi-threading features, where ChibiOS offer a more holistic approach through HAL, and it handles the HAL library. So ST's HAL or something else, and KIMSys as well. So ChibiOS is more onto that. Otherwise, the FreeRTOS is basically which gives you the power to create a basic preemptive scheduling. For a simple example of how to work with FreeRTOS, the HTTP server example by ST for the Nucleo board is a good start. But I have created few videos on my channel how to get started with the FreeRTOS. I haven't touched the ChibiOS, so I maybe create more videos on that if you let me know that you may need that. I will create the video related to ChibiOS as well. Now, as it says that ChibiOS is a lot larger than FreeRTOS in terms of its feature set. This becomes apparently when it comes to simply getting started with new ChibiOS project, where a FreeRTOS, as we saw earlier, can comfortably be just RTOS within a HAL, like KIMSys RTOS. ChibiOS has a lot of functionality which is not covered by that API. For this reason, the ChibiOS project has its own Eclipse-based IDE in terms of Chibi Studio, which comes with demo projects pre-installed. So if you want to touch the ChibiOS, you go with the this chibios.org library website, sorry, and you need to download this ChibiOS Studio. This studio is Eclipse based systems, and if you may aware with the ESP, the SCRT2 with the, I guess what it calls, Atomic True Studio, and that was the Eclipse based systems. Also in current version of the SCM32 IDE is also Eclipse based setup. So the Chibi Studio is free ARM development environment based on open source tools and components. It has been created in order to support these are basically you create a hall init function and shipping system initial and you pass like that function and example. Then you have a make file, just like any other C program. For the make file, you get all of these functionalities. You have the configuration file. The ChibiOS kernel comes with this file allow you scheduling algorithm, memory management, and to HAL are highly dependent on the specific microcontroller being used. For example, when enabling a driver in the HAL conf, the number of peripheral instances depends on the microcontroller in use. Similarly, the clock configuration or interrupt priorities are also extremely hardware dependent. All of these configurations are contained in the mcuconf.h file. So if you want to configure those interrupt priorities or hardware conf.h file, so these are the files that you can handle all of these. So that's how you create a very simple multi-threaded ChibiOS based tasks. So these are the basic things that you need to know about the ChibiOS. If you are interested to learn more about that, I will create some example projects on that. Just leave a comment that you want to know more about this and you may want to see the more projects related to the ChibiOS. Let's move the Hexter.io and find out some examples if we can find related to the ChibiOS and free RTOS. So let's see if we can discuss those projects, and let me search for that. And let's see if we can find something. I don't think so. Let's see if we find something related to the free RTOS. It has some examples: creating multitasking application, free RTOS based music display project with Wisnet, free RTOS multitasking in Arduino, implementing free RTOS on ESP32. I'm looking something which we may call some advanced things. AI powered pipeline leak detection. Okay, let's open up this. It has AI coral dashboard micro to listen for potential leaks. Okay, so what this project does, we will go over how to use the new coral dashboard micro for the Google from the Google. So this board is based on NXP based microcontrollers, and this board is from Google in a project that aims to detect small leaks via sound and then allow workers to remotely view the um, condition before a major fault occurs. To set up CPU architecture beyond the CPU cores and TPU. The curl dashboard micro will schematic and flash memory for storing program or file data in 64 megabyte SD RAM.
Near the top is an onboard Himax HM01B0 324 by 324 pixel color camera sensor. There is also an additional 2-lane MIPI CSI camera connector for activity and function as possible on the dev board micro alone. First is the wireless add-on board, and it contains a Murata Wi-Fi and Bluetooth module with support for up to Wi-Fi 5 and Bluetooth 5.0. Second, the Power over Ethernet or PoE board allows for the Coral Dev board micro on. Now, let's take a look at a more advanced example. It's possible to load the multi-core model cascade project taken from the Coral Micro repository and use it to experiment with running 2 models simultaneously. This allows